So we're finishing off this unit by talking and working with congruent triangles. And depending on where you went to school or whatever, you all have probably different junior high experiences, but you should have covered a lot of this stuff, so hopefully it will come back to you. Now, what does congruent mean? If you had to define the word congruent, these triangles are all congruent. They're the same. So congruent means identical. Now, people can argue, well, they're not the same triangle because that one's tilted. Okay? Well, that's like if in your living room, your mom flips the couch over and you're like, what happened to the couch? And you're like, well, I got a new couch. No, that's the old couch. No, it's not. Look how it's sitting. Totally new. That's a totally new couch. Okay? So, yeah, that doesn't make sense. Someone flips the couch. It's still the same couch, right? So those are all the same couches. They're just moved in different ways, right? They're not different. They all have the same angles and the same length of sides. That's what congruent is. Okay? Now, we don't want to get that mixed up with similar triangles. So let's go to the next page and talk about, so congruent triangles, you know, we're saying that if these two are congruent, that angle, see right here it says angle P equals angle L, so these two would be the same. And angle Q equals angle M, so these two would be the same. And angle R equals angle N, so these two would be the same, right? Also, to be congruent, PQ must equal LM. That's PQ, that's LM. QR must equal MN. QR equals MN. And PR equals LN. PR and LN. So, by looking at those are the same triangles. They have all the same sides, they all have all the same angles. And that would be your definition of congruent. Now, we're going to learn, or hopefully review, all these different triangles that exist to show congruency. Now, the theorems we're going to, do you remember these from junior high? Side, 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 angle, no, nothing. Okay, so let's start off. First of all, there's an angle. That means that if all the angles of this equal the angles of this, it doesn't necessarily mean that they're congruent. They would be called similar. Okay, similar but not necessarily congruent. I can give you 10 billion triangles that would have the same angles that are not the same size. Because angles don't depend on the length of the side. Okay? They're just enlargements or reductions. Now, there's side-side angle that we talk about a lot in actually 20-1, because this can have two cases. This is what's called the ambiguous case. See how this is a 1, 2.5, and then a 17-degree angle? This is also a 1, 2.5, and a 17-degree angle. So side-side angle can have different possibilities to it. Same with angle. Okay? Now these ones, and I wish I had this to give you, okay? But if I gave you three sides, 3 centimeter, 4 centimeter, 5 centimeter, every one of you would come up with the identical triangle. They'd all be the same size, okay? So if you have a triangle with a 3 centimeter side, 4 centimeter side, and 5 centimeters, so does the other person, I guarantee you they're the same exact triangle. Okay? So side, side, side means if all 3 sides equal the same 3 sides of another triangle, I guarantee they're congruent. Angle, side angle is also true. Do you see that if you had to draw this triangle, and this had to be 40, and this had to be 41, this had to be 49, there's only one triangle you can come up with, okay? Because this angle has to be 41, this length has to be 4, and this has to be 49 degrees. Now, these sides don't matter, because if you just drew this side like that, and you drew this side like that, they would all intersect right there. Okay? So if I said, you guys, I need you, and this is where we get angle, side, angle. It must be inclusive. You can't have an angle up here, then the side, then the angle. Okay? The angle, side, angle must all be touching. But if I said, you guys, I need you to have I want you to draw a 4 centimeter side and then 2 angles, a 41 and a 49 coming out here, all of you would come up with the same triangle unless you made a mistake. Okay? Now there's also the side angle side. If I gave you a 3 centimeter popsicle stick and I said, and a 2 centimeter, and I want those to meet, and they have to be 105, you would all do this. Okay? So you would get this popsicle stick, you would lay it down, and then you would move this one till it's 105 and put that one down. And I guarantee you, if I said, okay, can you just all measure that third side? You would all get the identical. Okay? So that's the side, angle, side. So it goes side, angle, side. Okay. Now, there is no angle. So these three you need to know. These are part of your proofs. So side, 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 ASA, and SAS. Okay? ASA and SAS. Okay? There's no ah or sa. Okay? You just have to know these three. Okay, so how are we going to use them? Well, I'll show you. Now, are these two triangles identical? Yes or no? And if you're saying yes, why? Which? Yep. Yeah, well, this goes X side O. This goes X side O. Even if this one went and these were mixed up, not that this triangle would look like this, but that would still be. They still have the same angle, side angle together. So this is definitely angle, side angle, same angle, side angle. So you would say they're congruent because of ASA. How about B? Nope, not congruent. There's no, remember, you only have these to pick from. Side, 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 angle, side, or angle, side, angle. That gives me no sides, right? So we don't know. This could be a little bigger than this one. It even kind of looks like it is. And I could draw the same exact triangle with those angles, right? That would be O, that would be Y, my X would be over there. That is not congruent. And yet I've done all the angles the same. Okay, how about C, yes or no? So it's congruent, why? So, side, side, side. Okay, now how about these two triangles? Would these be, so this triangle here, the blue one, and the red one, would they be identical triangles? Why? Okay, so which one of the top would you use? Angle, side, 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 angle, side. Side, angle, side? Well, we have a side and an angle. This has the same side because they put the little tick, angle. But how do I know that this is the same length for both of them because they share it, right? So we know that, right? They both, so that's side angle side, right? Side angle side, side angle side. So it's congruent. Side angle side. Okay, in the parallelogram ABCD, prove that triangle ABD is identical, is congruent. So that's what this means, just so you know. It's an equal sign with a little worm on top. I'm kidding, that's not a worm. That's a little squiggle. Okay, and that means congruent. So equal side with a worm means congruent. Okay, so I have to prove that A, B, D. So I'm going to do that with a yellow highlighter. This triangle ABD, I have to prove is identical to CBD. Okay, and here's one thing. In parallelogram, parallelogram means opposite sides are parallel. So these two are parallel. And then you could say that these two, we'll just put one little arrow, those two are parallel, right? Because it's a parallelogram. So I need to prove these triangles are identical. How would I do that? Yeah? No, this doesn't mean they're the same length. This just means they are parallel to each other, right? This means they would be the same length, but we don't know that. They don't give us that because that's not. They do share this side. B has to equal D. Why? Right. So if you guys could just kind of see this here, we have a Z. See this Z? So we could say that this would equal this, right? So we would say in our proof, number one, angle ADB equals angle, so ADB, no, sorry, I'm doing the wrong one right now. Angle, we're doing ABD is equal to angle CDB. And that's what we call alternate angles. We always have to support it with why we're doing it. Okay, what else could we do now? Using past stuff to prove that these two triangles are the same, the pink and the yellow. Well, here's the transversal though, right? That's that line cutting it. That wouldn't help me actually telling. Now, no, now we only have angle side right now. Are these two angles equal? Why? They're also alternate, right? If you turned your book, because you got two pairs of parallel lines, so step 2, angle, that's supposed to be a Y. I don't know, crappy looking Y. No. Okay, So triangle ADB, or angle ADB, I should say, equals angle CBD because of alternate angles. And 3, I would say that BD equals DB because it's the same side. Therefore, and therefore is 3 dots, we can say triangle ABD is congruent to triangle CBD. Why? Angle, side angle. This has O side Y. This has O side Y. So we would say because of angle, side angle. I wonder if you'll be getting any of these on your test. Okay, let's do one more. Let's really dig deep on this one because it's not as easy as the last one. I need to prove that AD, so from here to here, is equal to BC. So here's a proof in which we can't just say, you just can't get out your ruler and measure it. So we're looking for AD is equal to BC. How can I prove those two sides are the exact same length? All I've been given is this length here. It's 7, so that's 3 and then the 4, and this is 3 and 4. So that's all I've been given. This one you got to be kind of clever. No. I'll give you a hint on this one. This one's, if you can see this, this is where you want to start. What kind of triangle is that? It's an isosceles triangle. Therefore, this must equal this. Just by the law of the triangle, right? So we'll start off with saying that angle ABD equals, oh no, sorry, where am I? It's not ADB. I was totally looking at the wrong example. This is angle FDC, I guess, right? You could call it, yeah, FDC equals angle FCD. And that's, what am I using? Isosceles triangle. Okay. Now, I want you to focus on this angle here. Shouldn't this angle here equal this angle here? Because look at straight angle. Like we know that these two must add up to 180, right? So aren't those blue ones just 180 minus x? And since x is both the same, shouldn't it be, right? So we can say angle. Now we're going to call this, see this triangle? ACD. So angle ACD is equal to angle BDC. And that's straight angle. So now I know that y equals y. And then do you see that, see these two triangles here? This one and this one starting from here to here. Do you see they all share CD? They both, CD is their bottom. So CD equals DC. It's the same side. Now I've proven that these are identical triangles because they share this side. So this is a 3y1. This is a 3y line. So side angle side. It has both side angle side. So then I can say triangle ACD is congruent to triangle BDC because of side angle side. So do you see I've proven that these two yellow triangles are the same, therefore AD must equal BC because they are corresponding sides. So therefore AD equals BC. They are corresponding sides of congruent triangles. So this one especially is a very nice lesson to do with a partner because you could just go through and discuss, number one, what do you think? Yes, no, why? If you get to say yes, you have to back it up, right? And if you can't back it up, then you say no. Okay, so you look at number one, you're just going to look at the two triangles. Are they the same? Yes, because of this? No. There's nothing to support it. Okay, so you don't always have to be writing stuff down. I know teachers always make you have to write stuff down, but if you're talking about it, right, that's actually better than just writing it down and walking away. And it even you remember it better when maybe you have a bit of a disagreement and maybe the other person's right. I have found that a lot in my life. The other person always seems to be right. Okay, so we're doing 1 to 8 and 11 to 13.